Suppose your manager indicates that for a normally distributed data set you are analyzing, your company wants data points between z-scores of -1.3 and +1.3, standard deviations of the mean. Okay, so this wording may sound a little hard to process, but it's a way of saying and reminding us that z-scores represent a number of standard deviations from the mean. So what we're looking for are data points that fall within 1.3 standard deviations of the mean, below or above, as it also reiterates here, or within 1.3 standard deviations of the mean. What percent of the data points will fall in that range? So now what we want to do, since we're being asked for a percent, and probabilities and percentages are almost the same thing, just in a different format, what we want to find is the area in the region in between a z-score of -1.3 and +1.3. So this is like any other problem we've done before where we were looking for the area between two given boundaries. In a way, it could be seen as easier. There's multiple ways of approaching a problem like this when the two boundaries are the same distance away from the mean, from 0. I could just find this left area over here to the left of -1.3 using by looking it up in the negative z-score table. And then I would know that the same area would be in the right tail since the bell curve is symmetric and these values are the same distance from 0. And then I would know that if I subtracted the total of those two tails from 1, I would end up with the middle. So that's one approach. I could also use the more straightforward approach that you've used with any situation where you have two boundaries, whether they're the same distance from 0 or not. You could just do the larger left area, so the area from this +1.3, we could get the left area from that all the way back. And then we would have too great of an area, so we would want to subtract off the smaller left tail area, the area to the left of the negative boundary, or the smaller boundary in general. So either one of those would work. So let's go ahead and do both of them. The first one I mentioned is to find this left area here, the left tail area. And we can do that just by looking it up in the negative z-score table, or we can even use technology. We can use norm.dist in Excel with -1.3 as the boundary, the mean of 0, since these are z-scores, and the standard deviation of 1, again, because these are z-scores, it's a standard normal distribution, and then true for cumulative as always when using the normal distribution function. So there is my left tail area. Now, I know that the left tail area and the right tail area are the same, again, because the bell curve is symmetric and because the distance of this z-score, -1.3, that distance from 0 is identical to the distance between 0 and the positive z-score. So now I know that this right tail area also is 0.09 0.0968 as well, which means that the between area would be the total area under the curve minus 2 times that left tail area. So 2 of those, or adding them together and then subtracting from 1. Either way, that all makes the same result. And then we are asked to give it as a percent. So we can multiply this by 100 or just move the decimal place 2 places to the right. And then we want to follow the recommendations here. Enter a number between 0 and 100, not 0 and not 1. Okay, so it's just reminding us that we want to give the answer as a percent rather than a probability in decimal form. And then we also want to round to 2 decimal places. So after converting this to a percent, okay, 80.64% would be 2 decimal places. Okay, so that should be our answer. Okay, so there I used symmetry and the left tail area to get the answer. Now we've also previously learned how to find the between area by first finding the large left area. So that would be from all the way from here, all the way, all the way towards negative infinity. So that would be my left area, not my left tail, but the area to the left of 1.3. So I meant to say, let's call that larger left area, okay? And so that will be norm.dist with positive 1.3, a mean of 0, and a standard deviation of 1. True for cumulative. And now you can see that answer is larger than this right here because it's too much, right? What we want to do is we want to get rid of the region over here. So we're going to have to subtract whatever that part is right there, okay? That we have already is part of our answer so far. So we want to get rid of the left tail or the smaller left area, right? So smaller left area, which we happen to already know from doing the previous approach. Negative 1.3, mean of 0, standard deviation of 1, and true for cumulative. You can also put in a 1 if you want to say yes to cumulative. It's a shorter way of doing it. And so now we have the larger left area and the smaller left area. And to find the between area, we want to subtract the larger left area minus the smaller left area and find that we get the same answer as we did with the first approach.